Hello guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at three very important concepts in periodic tables and periodicity. The first is nuclear charge, the second is effective nuclear charge, and the third is screening or shielding effect. The nuclear charge is the total positive charge in the nucleus of an atom, and the magnitude of the nuclear charge depends on the number of protons in the nucleus of an atom. The nuclear charge is positive because protons are positively charged. As you move from left to right across a period, the nuclear charge increases because the number of protons increases. The magnitude of the nuclear charge affects how strongly the nucleus attracts electrons. The second concept we're going to look at is the concept of effective nuclear charge, which is represented by Z effect. The effective nuclear charge is the net positive charge that is experienced by an electron in a multi-electron atom. The mathematical relationship between effective nuclear charge and nuclear charge is as follows. Effective nuclear charge is equal to nuclear charge minus shielding constant. Now let us use the electrons in the sodium atom to explain the concept of effective nuclear charge. Sodium has 11 electrons. It also has 11 protons. So, the nuclear charge for a sodium atom is 11. The 11 electrons in sodium are arranged in three shells: the K shell, the L shell, and the M shell. The K shell comprises 2 electrons. The L shell comprises 8, and the M shell has just 1 electron. The electrons of the K shell and the L shell make up the core or inner electrons. The shielding constant, which is represented by S in this formula, represents the approximate number of inner or core electrons. Since the electrons in the K shell and the L shell represent the core or inner electrons, it means that the shielding constant for a sodium atom will be 2 plus 8, which is 10. So the value of S for a sodium atom is 10. The effective nuclear charge is going to be the nuclear charge minus the shielding constant, that is plus 11 minus 10, which is plus 1. Now, if we look at the value of the nuclear charge for sodium, which is plus 11, and look at the value of the effective nuclear charge for sodium, which is plus 1, you can see that the values are not the same. The value of effective nuclear charge is usually lower than the value of the nuclear charge because of the shielding effect due to the core or inner electrons. The third concept we're going to look at is the concept of screening or shielding effect. The shielding or screening effect is the reduction of the electrostatic forces of attraction between the nucleus and the outer electrons. This reduction in the electrostatic attractions of the nucleus for the outer electrons is as a result of the inner electrons. The inner electrons repel the outer electrons, and by so doing, they shield the outer electrons from experiencing the full magnitude of the nuclear charge. So, screening effect is simply the repulsion of the outer electrons by the inner electrons. As a result of that, they don't experience the full effect of the nuclear charge. And due to this, the force of attraction of the nucleus for the outer electrons is reduced. These three concepts that we looked at, nuclear charge, effective nuclear charge, and screening effect, are very important in analyzing the trends of properties that exhibit periodicity in the periodic table. They are also important in understanding the behavior of valence electrons. They are also important in chemical bonding. Thank you very much for watching, and see you in the next lesson.